Hi everyone, thanks for attending today's guest speaker sessions. Today we have Sara. So she's an AI researcher at Fondazione Bruno Kessler, Italy, where she works on speech processing and multimodal LLMs within the Between and DVPS Horizon European projects. She received her PhD cum laude in information engineering and computer science from University of Trento in 2024 with a focus on simultaneous speech translation and subtitling, and her research interests span multimodal and cross-lingual instruction following models, speech foundation models, and LLMs. So, yeah, great to have you here, Sarah. So, I'll leave it to you. Yeah, please go ahead.
Yeah, thanks again for having me. And in this talk, I will talk about cross-lingual evaluation, specifically of general purpose instruction following models across three core modalities: text, speech, and vision, and specifically videos. But first, yeah, sorry, I don't know why. Okay. But first, a couple of words about me. I have some visualization problems. Okay. Maybe I can share. It seems to be cut. There is this visualization here. I can maybe present. Can you see the full slide now? Okay, perfect. So yeah, a couple of words about me. I am an AI researcher on speech processing at FPK, or Fondazione Bruno Kessler in Italy. I received my PhD a couple of years ago, and my PhD was in computer science. And my main interests span speech and NLP topics, and I'm in those communities since 6 years now. But let's start with the talk. First, I will tell you why we need instruction following, even if I think that most of you already know it. But of course, in interacting with current LLMs, we are usually interacting with through natural language instructions, so we are not following any template. And we also usually use different languages, in the sense that I'm natively Italian speaker. Sometimes I can interact with the model in Italian, but maybe also in English. And also I expect the model to handle different modalities, because not only interacting with text, so with chatting with the LLM, but also I expect the model to be able to process other modalities such as speech and video, so I can ask the model to interact with some speech recordings, or videos like movies or TV series or presentations. And of course, instruction following, that is the ability of the model to follow the instruction, is becoming the unifying interface for doing several tasks, also multimodal tasks. And the goal nowadays is to build general purpose models. And this entails also the ability of models of having of reasoning in different languages, but also doing some cross-lingual reasoning. If I provide a material in English and I ask something in German, the model is expected to interpret both languages and to understand the concept from different languages simultaneously. But I also expect the model to be able to perceive the content in a multimodal way. So I'm not only processing one modality at a time, but also integrating the representation from different modalities. Simple instance of this is asking to the model, here this example, to explain the conclusion of a work based on the chart that is present on the slide. This is a very an instance of a multimodal interaction. And the current evaluation framework usually assesses all these characteristics individually. So we have benchmarks that are focused on a single modality. So we have, for instance, a benchmark assessing the speech understanding capabilities, the video understanding capabilities, the textual capabilities of the model. We also have a benchmark usually in a single language, unless some exceptions, and also primarily in English. And we have, especially in, for instance, in addressing, in assessing the performance of speech LLMs, so models capable of processing speech inputs. We often use like LibreSpeech dataset for assessing the capability of the model of doing the speech recognition. We use another dataset like FLIRS for the speech translation capability. So we don't have a benchmark that, or at least there are a few benchmarks assessing multiple tasks. And also another aspect that is often ignored in these evaluations is the capability of the model to process long context inputs, like very long speech or very long text, or also videos. Of course, the real world is a different thing, because of course it's highly multimodal. In this talk, I will focus, as I mentioned at the beginning, on 3 modalities: speech, video, and text. Of course, the real world is highly multilingual. We speak a lot of different languages, but also cross-lingual, as I mentioned before. It's highly multitask, and in this talk here, I will focus on 4 macro tasks that are the transcription or recognition, the translation, the summarization, and the question answering. And of course, the real world is natively long form, meaning that we are not usually processing one sentence at a time, but we have, in general, long context. And of course, these aspects bring some challenges in the multimodal, model processing. And the first one is the multimodality, because as I mentioned before, the model has to be able to integrate information across different modalities. So not only able to process one modality at a time, but also to jointly merge the important information from the various modalities, being the spoken and written, spoken and visual, written and visual, and so on and so forth. The second challenge is the multilinguality, because we expect the model to interpret the correct language with which it has to reply. So if of course, if I prompt the model in Italian, I expect the answer to be in Italian, but also if I provide a context in English and I ask some question in Italian, I expect the model to reply in Italian as well. So this cross-linguality aspect. The third challenge is the multitask, in the sense that the model is not often provided with explicit information about the task that should be executed. So the model has to follow the instruction and interpret the task from the instruction. So we never write explicitly, or rarely do the summarization task, do the question answering task, but instead we use natural instructions. And lastly, long form. Of course, models should be also able to process long stream of information, and identifying the relevant content that should be used for properly delivering an answer. And for this reason, we recently proposed a new benchmark that is called MCIF, that stands for Multimodal Cross-Lingual Instruction Following. And we designed this benchmark with 3 core principles. And the first one is that it should be based on natural human written instructions. So everything was human written and supervised. We also exploited natively multimodal long form content, and I will show you in a few seconds which content we are dealing with. And lastly, this benchmark is parallel across different dimensions, including the modalities, the languages, and also the context types that are long form or short form context. So processing one sentence at a time versus processing a very long text or video or speech. About the data, we collected paper presentations from the ACL anthology because they have this nice feature of being open source with a very good license, the CC by 4 license. And we selected the material, of course, by manually listening to the audio and watching the video to make sure that the content was of high quality, that the speech was audible, but also that it wasn't containing TTS generated speech, so automatically generated speech. And also we ensured that each sample, we only have one instance for each speaker in the benchmark. But of course, ACL presentations are scientific talks. And why scientific talks? Because they feature very interesting characteristics for us. First, because they usually have some slides containing the plots and graphics and tables and other graphical representation of the paper content, apart from the video of the speaker speaking. But also the speaker itself has different accents. We have many speakers with different accents. Even if the scientific talks, and even in this case, are usually in English, we cover, of course, different accents because in conferences, like ACL conferences, of course, the percentage of native speaker is not really big. And also, these videos are self-recorded, meaning that we also assess different recording settings, possibly also with background noise, that is very different from very clean speech and also very clean videos, super high quality videos that sometimes we are used to when building and using the benchmarks. Of course, this makes everything highly natively multimodal, and this is the reason why we selected scientific talks. A few words about the data that we collected, because we collected almost 2 hours for the transcription, translation, and question answering tasks, with a total of 21 talks. And for increasing representability of the summarization task, we considered 100 talks instead, with a total of 9 hours and 30 minutes, more or less. The average duration is 5 minutes and 40 seconds, with some talks exceeding 7 minutes and some others below 5 minutes. As I mentioned, both video and speech are provided. The material is natively long form, but we also provided an automatically segmented version for the short form of about 6 seconds of video or speech. About the annotation process, we have 2 types, let's say, of annotations. The first one is the monolingual in English, and we are the professionals for the transcription part. For the summarization, we leverage the original abstract that were already included in the ACL anthology. And for the question answering, instead, we created from scratch the question and answer pairs. So domain experts, that was, the colleagues working on this project, but also other domain experts. And for the crosslingual aspect, we cover German, Italian, Chinese as crosslingual languages. And for translation, summarization, and question answering, so translation of the transcript of the original abstracts and also of the question answer pairs created in the monolingual phase, we are the professionals. But everything was revised by domain experts, and also the original abstracts were also checked when collecting, in the phase of the collection, to make sure that we are complete and there were no formatting issue. And some details about the question answering part, because we annotated the data in such a way that we had at least 10 question answer pairs per talk, with a total of 220 unique pairs. And we also categorize them by source type and input modality. And the source type is the source that we use for formulating the questions and also the answers. We have a percentage of questions that are the same for all the talks, that are the general questions, like what is the name of the speaker, But we also created from scratch and tailored for each talk some questions based on the abstract and also on the transcript of the talk. And for the input modality instead, most of the question-answer pairs can be answered by looking at both the audio and the video, but some of them can be replied only by looking at the video-only questions, or alternatively, only looking at the transcript or listening to the audio. But we also included a set of not answerable questions to assess the ability of the model to understand if it has enough information to deliver an answer. And being an instruction following benchmark, we also need some instructions or the prompts that we provided to the model. And when possible, we don't mention explicitly the task to be performed, of course, the input modality, and we always refer to the context that we provide to the model as content. So it's not speech, video, or whatever, it's content. And when possible, we don't provide a target language. For instance, of course, simulating real-world human interaction means that also in the translation case, we mention the target language. But for instance, here we have an example for Italian question answering and its translation below in English. We mentioned that the original content is in English, but we don't mention explicitly that we want the answer in Italian, even if, of course, the model has to interpret that it has to deliver the answer in Italian. And we also devised two sets of prompts. The first one is the fix, in which we use a unique prompt for, of course, different prompt for each task, but a unique prompt following many evaluation frameworks that are also evaluation campaigns that exploit only a single prompt. But we also devised another set that is the mix set, in which we sample the prompt from among 10 different prompts that are different, but not so different in the sense that they are a reformulation of the unique prompt in order to assess both the variation of the model when the sensitivity of the model when varying the prompt that is used, but also to avoid biases of models that maybe are more trained on the prompt, the single prompt that we use in the fix set. About evaluation metrics, we use word error rate for recognition, Comet for translation, and BART score for question answering and summarization. And we avoided using LLM as a judge approaches because they are not really established for multimodal evaluation. So multimodal LLM as a judge is not really something that is super established in the community. There are a few works about them, and also usually modality dependent. So some SpeechLLM as a judge, VideoLLM as a judge, and also often they rely on paid models, so proprietary models, while instead using these metrics that are established and free. Makes it easier for people to evaluate their models, and they are in any case still neural-based metrics, apart from word error rate that is in any case the de facto metric for the recognition task. And we also evaluated several models, 23 state-of-the-art systems, and we selected them with the criteria of being open, at least open weights. So the weights were available on Hugging Face, but also they shouldn't be too big. Again, to make it easier for a user to replicate our evaluations, and we selected models with less than 20 billion parameters. But we added a comparison with a closed system that is Gemini 2.5 Flash. because it's always useful to have an idea of how the model behaves compared to a product like Gemini. And also the choice of Gemini was because it was the only multimodal model, the paid multimodal model that was able to process video and speech jointly, because, for instance, GPT was not able to process video and speech, but it was first calling the Whisper ASR API to get the transcript and then concatenating it to the video. But we were interested in assessing the multimodal capabilities. But anyhow, in the end, we have in our evaluation 7 LLMs, 5 SpeechLLMs and VideoLLMs, and 6 multimodal LLMs. So moving to the results, here we have first the recognition that really makes sense only for speech and speech plus video models. And I will always present results compared between short and long form processing, but also present results for both the fixed and mixed prompts, with the fixed being in the lighter color. So on the left, we have the SpeechLLMs, and on the right, we have the MLLMs here. And another important aspect to consider is that some multimodal LLMs, like Gemma 3 and Min-Lite Omni, we are not able to do long form processing. If we look at the results here, we see that some of these models, like graded speech and 5-4 multimodal, are capable of, as a SpeechLLMs, and also Ola and Gemini are obtained very good results. So here, the lower the better. So we have very, very good results, with the best one being the 5-4 multimodal. But we also see very bad results instead by some SpeechLLMs like Ultravox and also Min-Lite and Mini-CPM that show a very, very high word error rates, exceeding 150 or 200, meaning that the text is wrong and it was, for instance, 2 times the length of the original references. And if we look at the performance shift from short to long form, we also notice that there is some degradation that is somewhat expected, of course, because currently most models are trained on short form segments. And we also investigated the cause for this phenomena, and we saw that the main cause for this degradation was the under generation. Even if the model was allowed to generate a lot of tokens, so the maximum allowed tokens was a really big number. This is a real example taken from the models here, in which this transcript was the only piece of text provided for an entire talk of 6 minutes. And we also have an interesting behavior here, because Ola was the only one that was significantly improving when processing long form inputs. And by analyzing the results, we found that it was often ignoring the instruction that we were providing and sometimes transcribing the content of the slides. But this, with the same prompt, this was not the case for the long form. So in the long form, it was able instead to process, to interpret the instruction correctly. When we look at the robustness of models when using different prompts, we see that some of these models are not really robust. We see performance variation of up to 60 word error rate. That is really a lot. And this is pretty widespread among all the models, especially for some of them. But also for the long form, we see variations in almost all models. Moving to the translation task instead, we also have LLMs here on the left. And we see that, of course, as expected, LLMs are the best ones at performing this task, with some exceptions, but most of the results are outperforming here all the other multimodal models. But if we look at the multimodal models instead, we see both cases in which the models are pretty good at delivering a correct translation. The higher the better here, because it's a Comet score. But we also see a lot of very low scores, and like scores of 30, 40 is a very low Comet score. And some of them, like Desta and Quen 2.5 Omni, are degrading a lot when shifting from short to long form. Again, we look at the main reason for failures of models, and this was again under translation, so generating short text. So again, this is another real example from our models in which this piece of text, this translation, was delivered for an entire talk. But we see another interesting aspect here, because Gemini was improving of about 10 Comet scores, and we investigated why. And we found that sometimes in the short form, Gemini was hallucinating, so adding some extra text that was really not present in the content. For instance, here we asked for the translation. It was simplifying the text with these questions, but also there's another interesting example here that I should have included, in which when we asked for a translation into Italian, it was starting by writing a recipe for a dish, an Italian dish. And the second one, the second cause of degradation of the performance was the over elaboration, so including some reasoning parts, some special instruction that we really haven't provided to the model. And by comparing fix and mix subsets again, we see a performance shift of 5 to 7 Comet in some models. That is still significant, even if, of course, smaller compared to the recognition one, because humans can perceive a difference of 2 Comet points clearly. So, of course, 5 and 7 is pretty significant. And about question answering, here we have also the VideoLLMs, the third category here. It allows for an evaluation of all the 4 categories of the model. And we see 2 interesting things here, because the first one is that surprisingly, at least in my opinion, the LLMs were not the best one at doing this task. With the exception of Quen 3, the others were underperforming compared to other multimodal LLMs, but also speech and video LLMs. But regarding the other models, so speech, video, and multimodal LLMs, we see very unclear trends. So we see some models that are able to perform the tasks, and some other models that are not able at all. And if we look at the best and the worst results, we can also see that some of these models, like Brain Speech and Mini CPM, also obtain negative scores. But we have at least one model for each category that score a very good score in question answering. And again, looking at the possible problems, we saw that often when the score is bad, the answer was provided in the wrong language. For instance, here the question was in Italian and the output was in English. Or even because the model was just providing some random text, maybe some transcription, or maybe some other part of the video content. It's not clear, but it was clearly not replying to the to the question. And lastly, we also had a model that was refusing to provide an answer, just without any explanation, or because it was detecting our question as an illegal activity. And looking again at the fixed versus mixed results, we see again some variations, but this was surprisingly more pronounced in LLMs. So we have 4 LLMs that were varying significantly when at prompt reformulation. And then lastly, we have summarization. For this task, of course, only long evaluation makes sense, because it doesn't really make sense to summarize a 1 sentence, 2 sentences. And here we see that, unsurprisingly, LLMs are the best ones in general, so are the most reliable ones. And again, here we have some models able more or less to perform the task, and some others that are completely, serious failures. Yeah, as you can see here, some models score very, very high negative scores. Some other models are able to achieve good results, and here the SpeechLLMs are not really capable of performing properly this task. Analyzing again possible reasons for very negative scores here. Again, it was the wrong output language, and often also the instruction was ignored, providing transcription, or maybe starting the model was just starting describing the images of the that it found on the video, and so on. And again, we see some performance shift, not very present in all models, but in any case, some relevant performance shift between, with prompt reformulation. And since MCIF has this parallel design, it allows us also to compare the results under different aspects. And in this case here, we also exploited the categories of the question answers, and we picked the best results for each LLM, SpeechLLM, VideoLLM, and MLLM category by excluding Gemini. And if we look on the right, we see that unsurprisingly, SpeechLLMs are the best ones at replying to questions that can be replied only based on audio. But we also see that VideoLLMs, even if not accessing to the transcript, are able to somewhat deliver a good reply. In any case, it's a score between 30 and 35. Meaning that even if the answer was not explicitly contained in the slide, it was able to provide an answer that was acceptable, thanks to the context, most probably. But interestingly, we also see that the audiovisual questions, that are the majority, are better addressed by LLMs. Followed by SpeechLLMs and MLLMs. But this also means that MLLMs were not really benefiting from video modality. And again, if we look at the video-only questions, we see a similar phenomena to the audio ones. We see, of course, VideoLLMs performing the best, of course, as expected, but also we see that SpeechLLMs and MLLMs were performing the best comparably. So this means again that MLLMs are not really leveraging the video cues for replying to the questions. If we look at the results on the right again, we can see that the general questions are the easiest one, with a BERT score of 50, meaning that generic questions like what is the name of the speaker, or what are the authors of the paper, and so on and so forth, are definitely easier for models than the other questions that are based on transcript, but especially those based on abstract. And this means also that the questions that were tailored on the actual content of the paper were more difficult to understand, and also to provide a reply to those questions. And as I mentioned before, the parallel design of MCIF allows also for evaluating how well MLLMs are integrating the modalities. We had some insights before in the question answering, but here we have analyzed all the MLLMs in our work by providing only one of the three modalities, text, video, and speech, and also by providing speech and video jointly. And we can see here that, of course, as you might wonder now, speech and video processing is not of help. Often degrades instead the performance. So meaning that if you use either video and speech alone, the model is usually better at replying and fulfilling the requests, the instructions, than when it has to exploit both speech and video cues. And we also see that the speech modality is the most effective one at the moment, with the only exception of Qwen 2.5 Omni, in which we see that video slightly outperform all the speech modalities. In general, models are more effectively integrating the speech modality. And lastly, we cannot conclude anything about summarization because sometimes the video modality arts the performance, sometimes the speech plus video processing arts the performance, but sometimes also the speech is not really well exploited, like in mini CPM, for instance, here. And I want to spend 2 words about the usage of MCIF so far, because we use it for the evaluation as an official test set during the last IWSLT evaluation campaigns that are organized each year in spoken language technologies, and specifically translation. We used MCIF as an official benchmark, and also in the instruction following task, but also in other tasks. And this was used to evaluate SpeechLLMs that we are trained on different settings. We had the unconstrained settings, in which the model can be trained and can any type of pre-trained LLM, speech models, and so on can be used for building the model. But also we have a constraint setting in which we provided a list of data that can be leveraged for building the SpeechLLMs, and also specific models from which the participant has to start. And interestingly, the constraint settings, so models trained on the constraint settings were able to outperform the other trained on unconstrained settings, and even the baseline that was the 5-4 multimodal in some languages. And we are also organizing the 2026 edition. So if you're interested in assessing your SpeechLLM capabilities, I encourage you to look at this, to have a look at this link. And I would like to conclude with some main takeaways, because of course in this talk I presented this new multimodal cross-lingual benchmark called MCIF. It was human created and annotated, revised, and its main purpose is to evaluate instruction following models across different modalities. We also provided 23 state-of-the-art model evaluation with which you can compare your system with. And MCIF also provides the possibility to compare, to analyze your model in different dimensions, modalities. So evaluating what I've shown just before, how well the model is able to integrate different modalities, or how well the model is able to interpret the correct language with which it has to reply, but also how the performance are varying when the model is processing the long context, so the whole video, the whole speech, the whole text, instead of processing one sentence, two sentences at a time. And thanks to this parallel design, we also found some limitations of current models. And the first is, of course, the joint modality integration, the speech and video. We found that the integration of the two modalities together was harming the performance instead of helping the performance. And of course, we also found that long-form processing is still a challenge for most models. That is, we observed some degradation, very significant degradation in some tasks when processing long form. And also that summarization is a very hard task at the moment, but also question answering, especially if we consider the questions that we are tailored specifically on the talks, that sometimes is the case, of course. And I thank you for your attention. The benchmark has been already released on Hugging Face, also the code for the evaluation. And thank you again.
So if anyone have any questions, please go ahead.
So, hello, thank you
Hi.
for your presentation. Since there are no questions, I will ask mine, which is mainly probably due to some, I missed maybe something during your talk. Did you talk about how you really exploited multilinguality? Because I've seen that at the end, the data used was basically speeches recorded in English, which, okay, they contain accents, but the main language is English.
Yes, we specifically address the cross-linguality aspect because apart from English content, of course, the content, as you mentioned, is English only. But we asked the model to provide translation, but also asked many questions and some summarization and this task into the other three languages, so German, Italian, and Chinese. So it was more focused on the cross-linguality, that is MCIF stands for multimodal cross-lingual. That is an aspect of the multilinguality because it's jointly being able to handle multiple languages, but also with the context in another language, in this case English only, because of course scientific talks are usually in English. But yeah, so we address specifically this cross-linguality aspect.
Thank you very much.
Thank you for your question.
Okay, meanwhile, I'll ask a couple of questions. So what's the reason for choosing only like German, Italy, and Chinese, and why not like other languages?
Unfortunately, I mean, we didn't have budget for covering many languages, and of course, I mean, we exploited the languages that we are. I mean, the collaborators of this project we are supporting, let's say, because as you have seen, as also I presented, there are. Multiple passes over the data because we asked translators, but also we manually revised everything as domain experts. And of course, this is a pretty long process. And unfortunately, we don't have budget for additional languages, but it would be super good if we will have in the future the possibility to extend it to other languages.
Okay, got it. And I have one more final question in terms of a data cleaning aspect of it. At the start, you did mention that you discarded some like low quality recordings or the speech videos. Like, can you just explain on like what are the process you followed in terms of like how you evaluated like this is the really low quality? Like, is it like human like
Yeah.
it or okay?
Yeah, it was human process. We listened to all the material within the benchmark, and of course, CTS generated was pretty straightforward to detect, but we also listened to the entire material to check if the material was complete. Of course, if the audio was understandable, or if it was super low, or with a lot of background, and so on and so forth. Of course, some background is a lot, but it should be at least understandable for us humans.
Okay, yeah. Thank you so much.
Thank you for your question. Hi, Dominic.
Yeah, so thanks organizers for sharing the link openly. I'm happy that I could hear this. My question is about the lower quality speech, because I listened to some ACL 6060 presentations, and they are very high quality because they are prepared, and I think that the speakers also do retakes, so there is nice intonation, there are no hesitations. So it's not like this talk when you spoke spontaneously. So is there any other tested in the same domain but spontaneous? It will be more challenging.
Yeah, of course, but you were pretty lucky because I've heard a lot of hesitations in many presentations, and I've also discarded a lot of samples because of, maybe they were, recording in a very bad setting, and it was not really understandable. But I also heard a lot of hesitations. Of course, in general, some people are preparing for the registrations, so it would be nice to get some more spontaneous, even more spontaneous presentations. Unfortunately, this is really challenging, but if we manage to find this type of sources, it would be even better, of course, for future benchmarks.
Okay, I think we don't have any more questions, I guess. Okay. Yes, yeah. I think we can end the session. Yeah. Thank you, Sara, for the great presentation and really great slides, I'd say.
Thank you so much. Thank you so much. Thank you again for having me.
Yeah. Thank you so much. Yeah. Thanks everyone for attending. Yeah. Have a great day.